In January 2023, an e-commerce checkout API went dark during a flash sale. The engineering team identified the cause within minutes. AWS API Gateway's account-level throttling limit had been reached. Recovery took 47 minutes. Not because the fix was difficult, the limit increase that resolved the problem took 4 minutes to apply once it was submitted to the correct support channel, but because the 3 actions taken before it each extended the outage. The team increased client-side retry frequency, which raised load on a service that was already refusing requests above the throttling threshold. They redeployed the application, which added new connection establishment overhead during a window when every available connection was already constrained. They opened a support ticket through the general infrastructure queue rather than the service limits queue, adding 20 minutes to the response time. 43 minutes of wrong sequence, 4 minutes of correct action. The instinct when a production service fails is to act. Retry, scale up, redeploy, restart. These responses are correct for many failure modes, for application bugs, for infrastructure faults, for degraded dependencies. They are not always correct for limit failures, and for some types of limit failure, they actively worsen the situation before the team realizes what is happening. Limit recovery is a decision tree, not a checklist. The first node of that decision tree, which type of limit was hit, and what does that type of limit require to resolve, determines every action that follows. The correct action for a rate limit that resets automatically within 60 seconds is to stop hammering the endpoint and wait. Retrying immediately extends the throttle window. The correct action for a hard limit that cannot be raised is to reduce load below the ceiling and redesign the workload that drove consumption above it. Requesting a limit increase achieves nothing. The same response applied to both produces the right outcome for one and delays recovery for the other. Acting before reaching the first node of the decision tree is the pattern that turns a 4-minute fix into a 47-minute incident. The 4 types of limit failure each have a distinct recovery path, and the paths are not interchangeable. Auto-reset rate limits are the most recoverable. Many rate limits operate on time windows, a ceiling of requests per second, per minute, or per hour, and reset automatically when the window expires. The recovery action is to stop generating load at the throttled rate, wait for the window to reset, then resume at a rate that stays below the ceiling. The single most effective thing an application can do during this recovery window is implement exponential backoff. Waiting a short period after the first throttle response, doubling that wait after each subsequent one, and resuming only when the service confirms requests are succeeding again. Retrying immediately after a 429 response resets the throttle window and extends the outage. Quota limits that require a provider support request are recoverable but on a longer timeline. The application cannot resume full operation until the limit is raised. The recovery sequence is: implement backoff and load shedding in the application to reduce consumption below the current ceiling while the increase is being processed. Submit the limit increase request through the correct support channel with a clear description of the current ceiling and the value being requested, and resume full traffic only after the increase has been confirmed. Submitting a request to the wrong queue or without the information the support team needs to approve it adds significant time to a window where every minute of partial service affects customers. Hard limits have no increase path. Recovery requires changing the architecture. The immediate action is load shedding, reducing the volume of requests to a level the existing ceiling can sustain, even if that means serving fewer customers or disabling features. The medium-term action is distributing the load differently, spreading requests across regions, across account boundaries, or across service types that do not share the same ceiling. Recovery from a hard limit is measured in hours if the redesign is straightforward, or in days if it requires significant architectural change. Exhaustion recovery, where a resource pool has been fully depleted rather than a rate exceeded, requires controlled resource release before traffic is restored. For database connection pool exhaustion, the correct sequence is a rolling restart of application instances, taking a fraction of instances offline to release their held connections, waiting for the connection pool to partially refill, and bringing those instances back up before taking the next group down. Restarting all instances simultaneously releases all connections and immediately re-establishes all of them, redepleting the pool within seconds of restart completing across all 4 paths. State restoration is the step teams most consistently skip. When a limit failure causes requests to fail mid-flight, some of those requests may have been partially processed, a database write begun but not completed, a payment initiated but not confirmed, a file upload started but not finished. Restoring service availability does not resolve the state of these in-flight operations. Verifying what completed, what failed cleanly, and what is in an indeterminate state is part of recovery, not a post-incident task. The pressure of a live production outage makes the first node of the decision tree, which type of limit was hit, the step teams are most likely to skip. The monitoring is firing. Customers are affected. The impulse is to do something rather than diagnose before acting. This is the condition under which 43 minutes of wrong actions happen before 4 minutes of correct ones. The operational preparation that changes this is runbook documentation written before the incident. A runbook that maps limit types to recovery sequences, that says, if you are seeing a 429 on API Gateway, the recovery path is this. If you are seeing connection refused on RDS, the recovery path is that removes the diagnostic step from under pressure and places it in a document written when there was time to think. Teams that maintain limit runbooks recover faster, not because they act faster, but because they act correctly sooner. Recovery without understanding the cause also leads to a repeat of the same failure. A limit raised without understanding why it was hit will be hit again. A connection pool exhaustion resolved by restarting instances without addressing the auto-scaling policy that caused the depletion will exhaust again at the next traffic peak. The incident closes, the condition that produced it does not. The e-commerce team recovered in 47 minutes. The correct action, identifying the throttled limit, submitting the increase request to the service limits queue with the required information, took 4 minutes once they reached it. The 43 minutes before it was spent on responses that were reasonable under pressure and wrong for the failure mode in front of them. After a limit failure, the wall has been hit. The question is not what to do, it is which type of wall this is and which path leads back through it. That question comes first. Everything else follows from the answer.